Assalamu alaikum students. In today's lecture, I'm going to talk about the new topic that is basically indices 1. So there are some rules that we need to use before going on to this exercise. So the rule 1 for the indices, basically indices is the plural of the word index, and that means power. Okay. So if we have some powers with the numbers or some variables are having power, so how we need to deal with them? So there are some rules. So the first rule is that if you have similar bases, like if we have this number, so this is basically called the base. A is the base, and this you can say as your index or power. So this form is basically called the index form or indices. Okay, in plural, we will be saying indices. So the first rule is if you have the similar bases, like if we have the base A over here and here as well, we have base A, but the powers are N and M. So whenever we have similar bases with the multiplication sign, so you need to just add the powers together like N plus M. Okay. Further simplification you can do as they give us one example over here, that the similar bases we have are 7 and 7 and the powers are 2 and 4, so they just added up the power and they just wrote the base only one time. Okay, so this is your rule number 1. Next, for the second rule, if we have the similar bases but with the deviant sign, like similar bases with the different powers but with the deviant sign, so you need to subtract the powers and negative M. Okay, so powers are going to be subtracted. As they subtracted the powers here, 6 negative 2, they got 4. So this is your rule number 2. Next, for the third rule, if they have been given one power inside of the bracket and one outside, so you need to just multiply the powers together like n times m. Okay, so 3 5 times or 2 5 times is 10, and the power that they were having, they just wrote one time again. Okay. Okay, the next one rule that they gave us over here, this is basically the reciprocal power. We have a negative power here. So if we have a negative power, we can make it positive and we will just bring that into the denominator. Similarly, if in the denominator I'm having the negative power, I want to make it positive, so I will be bringing it up into the numerator. Fine. If we have a negative power, okay, like for example, negative and I'm having in the power in the denominator, so I will be bringing it up into the numerator. Just the way they gave us 5 raised to the power negative 2. And to make the power negative positive, they just brought this power into the denominator. So they got 1 by 5 raised to the power 2. Okay. So if we have been given a power with the fraction part, like for example, 1 by n they gave, so this basically means the nth root of a. Similarly, if we have like 1 by 2, we know that this is square root of a. If we have 1 by 3 power, this is the cube root of a. If we have 1 by 5 power, this is the fifth root of a. Similarly, if we have 1 by n, this will be the nth root of a. Okay, n is basically related to the numbers 1, 2, 3, 4, and so on. So accordingly, we can just write them down. So this means basically the nth root raised to the power m. Sometimes they gave the roots in this way as well, like 5 by 2. So this is basically the second one root or the square root of the raised to of the power 5. Okay. Similarly, if they gave the fifth root of raised power 3. Okay, fifth root raised to the power 3. So in this way as well, we can have some powers. So the last one rule is this one, that if we have been given a 0 power, so your answer will be always 1. Okay. So using these rules, we are going to solve some questions that they gave in the next exercise, that is your exercise 1.6a. So first of all, in this exercise, they are saying that you need to express all these numbers in the index form. So for representing them in the index form, we need to just represent them in the form of power. So first A1 part is 6 times 6. So when a number is being multiplied itself 2 times, so we can write that in the form of power like 6 square. Okay. Next, we have been given 4 that is being multiplied 1, 2, 3, 4, 5, 5 times together. So 4 times 4 times 4 times 4 times 4. We can simply make it as 4 raised to the power 5. Okay. Some different numbers if they give, so differently you can deal with them. 3 times 3 times 5 times 5. We can write them as 3 square and 5 square. Okay, so in this way, different numbers can be also written in the form of index. Next, for the fourth part, okay, for the fourth part, we have 2 times 2 times 2 times 11. If a number is not being written in the form of powers, you can just separately deal. So as 2 has been given 3 times, so we can write 2 raised to the power 3 times 11 for this fourth part. Okay. So, okay, let's go on for these right here. We have 1 by 8 raised to the power 3 here. Okay. For 6, 1, okay, let me write the answers directly as the question is in front of you. This. So what we can write for this is 1 by 3 raised to the power 3 and 7 raised to the power 2. Okay, as for the seventh one, they just gave us the square root, but we need to express them in the form of power, in the form of index. So you can just write 13 raised to the power 1 by 2. Okay, in this way you need to represent. For the eighth one, you will be writing 2 raised to the power 1 by 3, as this is the third root. And for this one, you need to write 10 raised to the power 1 by 5. Okay, so in this way, third root, fifth root has been given, so you need to write them in the index form, writing as 1 by 3, 1 by 2, 1 by 5, and so on. Okay. Okay, let's move on to the next one, 11th part. They're saying write as a single power of 3. Like all the powers has been given either with a multiplication, either with division sign. So here we will be using the indices rules, and accordingly we need to write them as single power. So 11 part is they have been given 3 raised to the power 2. It's 2 times 3 raised to the power 9. So as with the multiplication sign, they gave it the similar bases and different powers. So you need to add the powers together. So this will be 9 and 2, 11. Okay, so this has been given as single power as 3 raised to the power 11. Next, for the 12th one, they gave us 3 raised to the power 15, and we need to divide it by 3 raised to the power 7. So as division sign has been given, so we need to subtract the powers. Like from 15, you are going to subtract 16 because of the division sign. So 15 negative 7 will be 3 raised to the power 8. 12th part is done. Next, for 13th one, they gave 3 different powers with same base. So multiplication has been done, so we need to add all the powers. So you can add the 3 powers together at one time as well, like 3 plus 6 plus 8. Okay, and if now I'm going to add this 3, 6, and 8 together, it's basically 17. Okay, 3 raised to the power 17. Okay, next we need to go with 14th part. We are having 3 raised to the power 7 dividing with 3 raised to the power 10. So as division sign again, they have been given, so 7 negative 10 we will be doing. And 7 negative 10 is going to give us a negative power due to the 10 that is having a negative number. So we are going to have negative 3. But we can make this negative 3 as positive, like if we would be writing this into the form of denominator. Okay, that was your fifth rule. So it's not fourth rule, in which we need to make the negative power positive. Okay. Okay, 15th one, they have been given as 3 raised to the power 5 raised to the power 4. So here the powers can be multiplied together. Okay, if they have given the powers in the form of brackets, so you can multiply the powers directly, like 5 4 times will be 20, like this. Okay, now last one, they have been given, okay, let's do it under this. We have been given 1 2 3 4 4 times 3 together, so 3 raised to the power 4 you can represent. So in this way the rules of indices can be used, but this one exercise was quite easier. Like here, just we need to go with a very basic thing, writing the powers in the form of index, or just doing some simple rules to write them in the single power. Okay, this was your exercise 1.6a. Now moving towards exercise 1.6b, here they are just asking for the evaluation. And again, we are going to use the similar rules. Okay, so let's go on with the first part, as they give 3 square times 3. So 3 square times 3, if this 3 is not having any power, we can consider the power 1 over the top. Like if any number is not having power, there is understood that power 1 is existing. So we need to add the powers as the numbers are being multiplied together with a similar basis. So 3 raised to the power 3. So if we want to go with 3 raised to the power 3 solution, that would be 27. Okay. 3 times 9, 9 3 times would be 27. Okay. Next, for the second one, we have 100 raised to the power 0. So any number to the power 0 always gives us 1. So this you need to remember. Next, for the third one, they gave us 3 raised to the power -2. So to make it positive, we can just write it in the denominator, like we can make it 3 raised to the power +2 in the denominator. That would be 3 square 9, 1 by 9. Okay. Moving towards the fourth one, we have been given 5 raised to the power -1 raised to the power -2. So -2 and -2 would be multiplying together. So negative, negative, positive to 1 times 2, and 5 square is 25. So we have been done up till part number 4. Let's go on with the part number 5. We have 4 raised to the power 1 by 2. So simply 4, if I will be writing in the form of power, I'm going to write 2 square. And this 1 by 2 that they gave, we can write it outside. So cancelling the 2's together, we are only left with the 2. Okay, in this way, the evaluation you can also done. Similarly, they gave 16 raised to the power 1 by 2. So we know that 16 is basically the square for the 2. So 4 square is 16. This 1 by 2 you can write similar. 2 will be cancelled out with the 2, and your answer will be just 4. In this way, you need to work with the 7th one as well. Some of them you can try yourself. 8th one, we have 8 raised to the power 1 by 3. 8 basically you can write 2 raised to the power 3. Okay. This is basically 8. Like if I'm going to make 8 as vectors, so 2 4 times, 2 2 times, 2 1 times. So 2 raised to the power 3 will make us 8. So this 1 by 3 you can write outside of the bracket, and cancelling the 3's together, you are left with the 2 only. Okay. Yeah, this 9th one is an example that we were discussing. 9th one, they gave us that 9 nth root of 9 raised to the power 3. Okay. So we have been given 9 3 by 2. Again, 9, if I will be checking, this is basically 3 square. And this 3 by 2 you can write outside. So 2 would be cancelled out with the 2. Only 3 power 3 is remaining. That is basically 27. Okay, so this is part number 9 we have done. So in this way, we need to keep on going with some questions. So let's work on the 10th one. As they gave 27 raised to the power 1 by 3. So 27, we can simply write 3 raised to the power 3. This 1 by 3 similar outside, cancelling the 3's together, and we are left with the 3 only. As for the 11th one, they gave it the negative power, -1 by 2. So similar working we need to do. First, we will be writing this 9 as 3 square and -1 by 2 as it is. Cancelling the 2's together, we have 3 raised to the power -1. And to make it positive, we will be only writing it as 1 by 3. Okay, like this. Okay, next is part number 12. It's also quite similar. We have 8 raised to the power -1 by 3. 8 you can write as 2 power 3. Okay, and this -1 by 3 as it is. Cancelling the 3's, and we have 2 x power -1. Make it positive by bringing that into the denominator simply. Okay. Okay, 13th one is simple. 1 to the power, 1 to the any power, we are going to have 1 again. So no need to simplify, just quickly write down the 1 again. 14th one is exactly similar to the 2 parts we have done 11th and 12th. You can write 5 square, cancelling the 2's, and just making this as 1 by 5 to make it positive. So hope so this will be fine. 15th one we can go on with. They gave us 1000 raised to the power 1 by 3. 1000 you can write as 10 raised to the power 3. This 1 by 3 outside as it is, cancelling the 3's together, and you are left with the 10 only. Okay. So you can check that indices makes your calculation very easy and quick. So we have 2 raised to the power -2 times 2 raised to the power 5. Again, the rule is going to be applied. The first one rule, as the bases are similar and the multiplication sign is there, so you need to add the powers -2 +5. And -2 +5 will be 2 raised to the power 3, and that will be 8. 2 raised to the power 3 is basically 8. Moving towards the next part, that is part number 17 we have. So here again, similar bases we have, but different powers with the deviant sign. So we need to subtract the powers this time. But as your one power is already negative, so check it carefully that how we'll be writing the powers in the negative form. We need to write 2 raised to the power 4 negative into negative 1, because one negative power they already gave and one negative sign we need to apply ourselves. So negative negative will be positive, 4 plus 1, and what it will be is 5. 2 raised to the power 5 and 2 raised to the power 5 will be 32. Okay. So in this way, they already gave you the negative sign, so you can deal with the negative signs like this. Fine. This is your part number 17. Let's moving towards part number 18. We have 18 part as 8 raised to the power 2 by 3. So again, they gave with the fractional power. So 8 we can write as 2 raised to the power 3, and the power above will be 2 by 3. So the 3's we can cancel out and only 2 raised to the power 2 is remaining. That will be 4. Okay. So next 27, they gave us almost similar. Just the thing is that they gave it a negative power as we have 19th one. We have been given 27 raised to the power negative 2 by 3. So 27 you can make it into 3 power 3 and the outside negative 2 by 3 as it is, cancelling 3's and 3 raised to the power negative 2. 3 raised to the power negative 2 you can't deal unless you will make it positive. So for that you will be bringing that one in the denominator and then 3 square will be 1 by 9. Okay. And this way you can work with these. So some random questions from this I'm going to pick up so that some of them you can try yourself. Okay. So let's go on with 25th. 25th we have been given as 9 raised to the power 1 by 2 raised to the power negative 2. So here again, like directly you can cancel out the powers together and only 9 raised to the power 1 negative 1 you are having. So you can make it as 1 by 9. Check 21st. They have been given with the different bases and different powers. So how we will be dealing with this question? We have 36 raised to the power 1 by 2 and 27 raised to the power 1 by 3. First of all, this 27, 36 as they give us a power 1 by 2. So we know that we can write it as 6 square. And this 1 by 2 power similarly you can write. And 27 you can write as 3 cube and power 1 by 3 as it is. Cancelling the 2's and 3's together, we have only 6 times 3 and 6 3 times is 18. Okay. In this way as well, some of the questions simplification can work. Okay, the questions in which we have thousands or hundreds, these are very quick to work with. We have 22nd over here. We have 100. Okay, we have 10,000 and raised to the power 1 by 4. So 10,000 is going to have how many zeros together? 4 zeros, and this 1 by 4 as it is. Canceling the 4's only, we have 10 remaining. Okay, let's go on with 24th. As this is having a negative power, we have 100 raised to the power 1 by 2 raised to the power negative 3. 100 we can make as 10 raised to the power 2. Writing this 1 by 2, you can just times it by 1 by 2 and writing this negative 3 outside as it is. Cancelling the 2's, we have only 10 raised to the power negative 3 remaining that you can make as in the denominator to make it positive, and this will be 1 by 1000. Okay. In this way, these questions can work. Again, this one is having power 0, so you can directly write 1. Whatsoever the number is there, either positive, either negative. If your number is having the power 0, you need to write the answer as 1. Okay. So just the way I performed this 21st, this 27th is similar. Let's go on with this. We have 81 raised to the power 1 by 4, and we need to divide it by 16 raised to the power 1 by 4. Okay. So 81 we can write this one as well with the power, and 16 as well we need to write with some kind of power so that we can deal with them. So 81 we can write as 3 raised to the power 4, as 3 power 4 will give us 81 times by 1 by 4 as it is. 16 we can write as 2 raised to the power 4 and 1 by 4 as is. When your like basis you can't make the basis similar, you can make the power similar in this way that cancelling will give you simple numbers. Okay. like canceling these 4s, we have only 3 dividing by 2 is remaining. That will be simply 3 by 2. You can just leave it in the form of fraction or either make it into the decimal form. So this will be up to you. Okay, simplification is totally up to you. Like if I will be dividing this into decimal point, it will be giving me 1.5. Okay, so again here they give 1 raised to the power 4 by 3. Answer will be 1. Simple. Okay. 1 raised to the power, like 1 to the any power, answer will be 1. Okay, let's check that's 35 part, and in this they gave us 0.01 raised to the power 1 by 2. For these questions, it will be better if you will make them in the form of like without decimal point. If you can make it in the form of fraction and then just go on. So it will be 10 square. This 1 by 2 you can multiply, because 1 raised to the power, any power, you can just go on with a 1. Canceling the 2's, 1 by 10 is remaining. Okay, in this way they will be easier. Let's go on with 36 as well. This is also quite similar. We have 0.04 raised to the power 1 by 2. Okay, if I will make it into the fraction form, I will be writing it as 4 by 100 and writing 1 by 2 as it is. 4 is basically 2 square, 100 is basically 10 square, writing 1 by 2 as it is. Just make this 1 by 2 with both of the powers separately. You can multiply like this. And cancelling the powers, it will be 2 by 10, that will be 0.2. Okay. Again, this will be 1. Fine. Bases are similar, multiplication sign is there, you need to add the powers. Okay, let's go on with this, how we'll be working with 40th part. Okay. Part number 40, we have 3 into 3 by 8 raised to the power 1 by 3. Okay, for this first you can make it into the improper fraction, as this is in the form of mixed fraction. So 8 3 times first we will go, and then whatsoever the number we are going to get, we need to add 3. Okay, so 8 times 3 is basically 24, and 24 adding 3 in that, it will be 27. So we can write it as 27 by 8 raised to the power 1 by 3. So 27 we can write as 3 raised to the power 3, and 8 you can write as 2 raised to the power 3, and this power 1 by 3 with both of them. Then you can just separate out this 1 by 3 with both of these like this. So cancelling the powers, we will be only having 3 by 2, that you can write 1 into 1 by 2. Okay. So this was your part number 40th. Similarly, let's go with the part number 41st as well. As this one is almost similar, just the thing is they gave us a negative power. So let's see how we will be dealing with this. Negative 1 by 2. Okay. 11 9 times will be 99, and plus 1 will be 100 by 9 raised to the power negative 1 by 2. 100 is 10 square, 9 is 3 square. Writing negative 1 by 2, writing negative 1 by 2 with both of them separately. Like this. Both powers will be having like negative sign, so you can just make it positive by bringing this 3 in the numerator and 10 in the denominator. So this can be also one way. So 0.3 will be your answer. Okay. So hope so these are getting clear. So let's move on to the next part. So I'm just going to pick up some questions that might be difficult, or some confusions you might have. Rest you can try it, because the questions are quite easier. Just you need to keep the rules in your mind, and then they will be easier. Okay, we have 10 raised to the power negative 6 raised to the power 1 by 3. Cancel them out, like 3 2 times is 6. Only powers needs to be cancelled out with the powers. Okay, we can't cancel them out with the numbers. So the power that we left with is 10 raised to the power negative 2, and that you can make it positive, and you will be bringing that into the denominator. So 10 raised to the power 2 will be simply 100. Okay. Okay, let's go on with these type of questions when they gave some powers in this way. So we need to first solve it a bit, and then we will apply the rule. So we have 7 raised to the power 1 by 2 raised to the power 4. Here you can just simplify the power, like 2 times 4, so 7 square dividing with 7 square. Bases are similar, so power needs to be subtracted, as division sign is being given. So 2 negative 2 we need to go. 2 negative 2 will be 0, and any number to the power 0, the answer will be simply 1. Okay. This is your 46th part. Let's go on with 47th. As in the 47th, they gave us, let's see, we have 0.0001 raised to the power negative 1 by 2. So first, let's make it into the form of fraction. We have 1, 1, 2, 3, 4. 4 zeros you need to make it after. And then negative 1 by 2 as it is. As the power is negative 1 by 2, to make it positive, we will just change this fraction, like we will invert the fraction. We will be only having this 10,000 in the numerator, and the power will be changed into 1 by 2. Okay, so how many zeros we have? 4 zeros we have, and keeping this 1 by 2 as it is, to 2 times is 4. 10 raised to the power 2 is remaining, that is basically 100. Okay, so in this way, these questions can work. So next we have this 48th one. We have 9 raised to the power 1 by 2 and 4 raised to the power negative 1 by 2. Okay. First, we need to simplify this. As 9 we can write as 3 square, 1 by 2 as it is. 4 we can write as 2 square, negative 1 by 2 as it is. Cancelling the powers, we have 3 by 2 raised to the power negative 1. So to make this 2 negative 1 positive, you will be bringing that into the numerator, and 3 2 times will be 6. So this one is your part number 48. Okay, in this way as well, you can work with the powers. If your power is negative in the denominator, you can bring that into the numerator and multiply if there is still any number in the numerator. Fine. Okay, let's go on with the 49th part. We have been given as 25 raised to the power 3 by 2 times 4 raised to the power 1 by 2. In the denominator, we have 9 raised to the power negative 1 by 2. Okay. First, write them all with the squares. Like 25 is 5 square, times it by 3 by 2. 4 is as 2 square, times it by 1 by 2. 9 is of 3 square, times it by negative 1 by 2. Cancelling all the 2's together in the powers, we have 5 raised to the power 3, 2 raised to the power 1, 3 raised to the power negative 1. So 5 raised to the power 3 is basically 125. This 3 you can bring in the numerator. So 125 times 3, 2 times 6, we can just multiply 125 by 6. And it's giving me 750. Okay. This is your part number 49. Now the last part is the 50th one. We have been given negative 1 by 7 raised to the power 2 dividing with negative 1 by 7 raised to the power 3. Again, bases are similar. Both bases are negative 1 by 7, negative 1 by 7. So and deviant sign is being given. So we are going to subtract the power, writing this base one time only. So we are going to write 2 negative 3. So if 2 negative 3, I'm going to deal, it will be negative 1. But to make this negative 1 positive, you need to make this, like you will invert this fraction. Negative 1 by 7 to negative 7, and only power 1 will be there. So no need to represent the power 1. Also one thing, like when you are inverting the power, you no need to change the negative sign. Like you will not turn into this negative sign, you will not turn into positive sign. Okay, so sign will be similar, just 1 by 7 will be 7 by 1. So I'm just keeping this writing 1 in the denominator, so you can simply keep it as negative 7. Okay, so this was your complete exercise, and hope so this exercise is clear. See you in the next lecture then. Allah Hafiz.